Welcome to a new test and teardown video. Yeah, we're going to continue a little bit with homebrew stuff. I got quite a lot from this same dude. Oh, sorry about that. This one is really nice as well. So, by looking at the meters and the indications here, see it says 0.3 or 3 amps. So I guess this is 30 volts, 3 amp power supply. The case is an MK case, and the top and the bottom, that is actually steel, powder coated, and the back and the front, that is aluminum. There's a beautiful design here. Everything is nice and straight, and the meters is nice and straight, and those are in the middle, symmetric. I really like this, the way that the homebrew here is done. Also, yeah, look at that. It is huge, but of course it is so heavy. But look at the heat sinks, how well they fit the case. It is just absolutely perfect. Fantastic job here. Oy. Oh, yeah. From the side. I can't wait to try and power this up and see if it works. And mains is applied. 6 watts. Yeah, this is the fold back. So this one got exactly the same system as all the other power supplies I tested. See? Now it is enabled. So this means fold back is enabled, and this means constant current mode is enabled when in overload condition. So this is, yeah. And this is fine. And it goes to, yeah, a little bit under 30 volts. There is a detectable hum. I don't know if if you're able to hear this. Let's try and measure the output. Okay, voltmeter is a little bit too friendly, about 1 volt too much. Let's go to 10, like that. And okay, it's a little bit high. Maybe it's the 0 that is not correct. Let's try and turn it off. Nope, this is quite alright with the 0. I think we should try and load this thing, shouldn't we? Look at that. That is exactly 1 amp. And that is super accurate. So this will be 20 watts output. And the power usage is 52 watts. How about we crank up 2 amps, 3 amps. Okay, and back again. So that was 3 amps. Let's try and see where's the limit. I cranked up the amp setting. 3.1, 2, 3. Okay. And then that is 3.2. So it gives a little bit more than promised. And that is 3 again. So that is 63 watts output at the moment and 140 watts input. How about we crank this? Ooh. So there is something. It wants to tell me there is not enough voltage available. So that is 25 volts and 3 amps output, 76 watts and 140 watt mains usage. I bet nothing yet. It's probably gonna come in a minute. But those power supplies are, those heat sinks, sorry, they're just super big. So that would definitely take quite a lot of time, and it's probably sharing the current between the two transistors really well. I can feel a little bit, but this is nothing. There's a super good thermal. This is not bad at all. How about I do this? Okay, now it's 3 volts and 3 amp. That is 10 watts of output, right? And now we have 140 watts input. So how long is it going to take? Yeah. Well, that was a difference. So this is exactly what happens with a linear power supply, right? But both of them, they get hot exactly equally fast. Super. They're sharing this perfectly fine. Now I'm going to open it and show you what is inside. Now we're inside the fantastic 3 amp power supply, and it is not a big surprise. It is the same. Oops, let's turn off the mains supply. So it is the same power supply controller PCB. Obviously he got this somewhere. I don't know exactly where. And it's the same voltages he's using, and it's also the same mains transformers. But now he's like using 2 of them in parallel. And we got 45 volts here, and this one is dropping to 33 at 3 amps. And this is of course why the output is dropping a little bit, and then you start getting a little bit of a ripple if you're near the 30 volts output. So, but from 28 or less, then you can load it with the full 3 amps and have no ripple issues. And like I see here, it's exactly the same implementation of more or less all the mods as well. Main rectifier is a big, strong, sized rectifier, and so that will be mains input, the 2 green one. But he's also using green as AC here and AC that one. So this is a little bit dangerous and a little bit confusing. Green here is mains, and then you see, I mean, that is not, I would have preferred to use the same brown then, at least. So you could see there's a secondary and there's a secondary, but anyway. And then there's the auxiliary supply, only from one of the transformers. Goes to the auxiliary system and the auxiliary capacitors. And this is the pre-driver to the 2 output transistors on the big heat sinks. And it looks like the 2 transistors, they're in parallel, but that, well, they are more or less also that. Look at that. That is a big emitter resistor for current sharing. So there's a local feedback emitter resistor. This is a very, very normal way to do this. And this will give you a perfect current sharing. And this is also why they got exactly the same speed, hot when I was loading this one quite a lot. And I really like the way that he built this with the big aluminum plate here at the bottom, transformers mounted on that, everything here is mounted on this. So when you look at the outside, there isn't really any holes here, there isn't any holes in the bottom plate. You can even take away the bottom part of the chassis and then access all the screws and nuts and stuff from the back. So this is definitely somebody who knows how to implement really cool things into this MK case. And I really like the MK cases. I've built a lot of cool equipment into MK cases when I was a kid. So that is very nice for me to see those again.